You're not allowed to plug solar panels into a socket in the UK, even though I just have. Yet the government has funded a £90,000 study to see if that should change. So rather than wait for the paperwork, I'm putting it to the test and asking whether this is the next evolution of solar in the UK. Of course, we wouldn't be trailblazing here. Plug-in solar, or DIY solar, often called balcony solar, is booming in Germany, with nearly 1 million installations already in service. Belgium has adopted it too. What's the big issue? The concern isn't the panels, it's the plug. Is it really safe to send power the wrong way through a UK socket? But before we get to the problems, let's look at the potential. This is a typical German style setup. 2 panels with a combined peak output of just over 800 watts. Over the course of a year, I estimate they generate around 750 kilowatt hours of energy. At current electricity prices, that's roughly £190 in savings. Based on what I've installed here, that's a payback of less than 2 years. Of course, that assumes you can use most of the energy as it's generated, rather than exporting it cheaply and still buying from the grid later. So I've paired the system with a DJI Power 2000, which we featured in an earlier video, and expanded it to 6 kilowatt hours of storage. We'll take a closer look at that in a moment. It's the sunniest day of the year so far, and the results are already encouraging. Over 500 watts of generation from the panels. Some of that's going to power the house, things like the router, the fridge, things that are left on all the time, and the rest, about 400 watts, is flowing into the battery. So is this setup actually dangerous? So here's our 13 amp plug with the power flowing back into it. There is certainly voltage present. We can hear the voltage tester there bleeping away, but you'll notice as soon as I unplug this, the voltage is gone. There is nothing on these pins because the microinverter is also fitted with anti-islanding protection. So as soon as it detects that the mains is gone, it shuts down. Perfectly safe. If we were worried about the socket situation, we could easily make it a compliant installation to UK standards by changing that for an isolator, because it is connected back to a dedicated circuit here in this distribution board. But that's not the end of our worries. There is a lot of talk when it comes to renewables about reverse power flow going through RCDs and RCBOs, and we've got one fitted in this board here. The worry is that when the power flows in the wrong direction and you push that test button, power hasn't disconnected quick enough to isolate the circuitry that's inside the RCBO, and that can actually blow the device up, and we have actually shown that on the channel before. So it's a brave moment. We're about to do that. I'm going to push the test button. The device has tripped off, but if I carry on and keep pushing the test button, previously we demonstrated that did destroy the electronics, so I'm going to hold that in and reset. No, that doesn't seem to be an issue. With 1 million installations in Germany, you would have thought there would have been discussion about that problem already. The other potential problem when it comes to inverter technology is the potential that they could generate a DC leakage current, which in older RCD technology can saturate the core inside the device, meaning they don't trip in the event of a fault. Not a problem here because we've got a Type A, but in other parts of this installation, there are older Type AC RCBOs, which could suffer from that. Now, when I looked into the design of microinverters, they are quite a chunky beast actually, and the reason for that is they are for an isolated construction, meaning the DC side is properly isolated from the AC side, which is not the case on many battery hybrid inverters. So perhaps that's a problem that we don't have to worry about. Based on what we've tested here, I can't see any obvious safety risks. That doesn't mean every plug-in solar product behaves the same way, and there may well be designs out there that would cause concern. If you've seen installations or accessories that worry you, let me know in the comments. The issue isn't controlled deployment, it's uncontrolled scaling. Here we've got one inverter rated at 800 watts peak and a battery system also capable of exporting up to 800 watts back into the existing wiring. But what happens if someone starts adding multiple units onto the same circuit or runs them through extension leads, particularly when parts of the installation are mounted outside? That's where potential safety issues could start to creep in, which is why it'll be interesting to see the conclusions of the official report, because clear guidance would be welcome. The reality is this equipment is already freely available. I bought this micro inverter from a well-known online retailer. Yes, it shipped from Germany, but I was also able to obtain a pre-made mains lead compatible with a standard UK socket. I've now integrated this plug-in solar setup with the Power 2000 plug-in storage solution from DJI that we featured a few months ago. Out of the box, the unit unit comes with 2 kilowatt hours of storage and integrates with a Shelly Pro power meter to create a simple plug-and-play grid-tied storage system. We've also used the additional channel on the Shelly Pro to monitor the circuit that the solar PV is connected to, rather than use the micro inverter app. That gives us independent visibility of what's actually happening on the wiring. I've added 2 expansion packs, boosting total storage to 6 kilowatt hours. It's worth noting that the expansion packs increase capacity, not export power. The grid-tied output remains capped at 800 watts, but in theory, on a good day, I could be drawing 800 watts from the solar inverter and 800 watts from the battery simultaneously, plus additional power from the front-mounted socket outlets. So while the export limit stays the same, the available energy and flexibility increase significantly. Expanding it is straightforward. You stack the battery packs together, connect them using the supplied leads, and on power up, the main unit instantly recognizes the additional capacity. You can monitor state of charge in the app or on the built-in LCD screen. I've configured the battery for overnight arbitrage, charging on an off-peak tariff at 7 pence per kilowatt hour. After running this for a few months, I've been comparing the input and output energy figures shown in the app. The round-trip efficiency is around 70%, and to DJI's credit, that data is easy to see. They make the energy in and energy out clearly visible, which isn't something every manufacturer does. Now, 70% might seem low to some people, but there are good technical reasons for it. Every time you charge and discharge a battery, you incur losses: AC to DC conversion, DC to AC conversion, internal resistance within the cells, and standby consumption. I also suspect DJI are using an isolated topology similar to what you'd find in microinverters, which adds an extra layer of electrical separation and safety, but inevitably introduces some additional efficiency losses. In real terms, that means I'm effectively paying around 10 pence per kilowatt hour for usable stored energy. When peak electricity is about 27 pence per kilowatt hour, that works out at roughly £1 per day in savings from arbitrage alone. On that basis, you're looking at roughly a 7-year payback on the storage technology, potentially better depending on when you buy the kit and how energy prices move. What will be interesting is seeing the impact of the solar integration over the coming months. Even while filming this video today, we've stored an additional 1.3 kilowatt hours that would otherwise have been exported to the grid. I've positioned the battery pack next to my desk because I find the bank of USB outlets on the front incredibly useful for fast charging devices. It also provides a built-in UPS function, keeping essential equipment powered from the front sockets if there's a loss of supply. That really came into its own last month when the DNO was carrying out planned maintenance on the local network. Now, in the UK, fixed battery storage systems are very much in focus ahead of Amendment for BS 7671. But this raises an interesting question. Is this a fixed system? I'm renting this house. When I leave, I'll unplug the battery, remove the solar panels, and take the entire setup with me. I haven't made any alterations to the fixed wiring, so where does that sit? We'll be following these developments carefully. Make sure you check out the webpage on efix.co.uk. The link is in the description, where we explore this topic in more detail, and you can learn more about the solutions we've used in this video. So let me know in the comments what you think of plug-in solar, the concept behind it, and even what this installation looks like here. Would you get away with it in your garden?